Okay, so the next part of this is, what if whatever's under the radical has a lot going on and you're not sure sort of what your answer is supposed to look like or how to approach it. So I'm going to approach this similar to my last video, where whenever there are numbers underneath the radical, I need to focus on the root first, and I make myself a little chart of numbers. Okay, so 2 cubed is 8, 3 cubed is 27, and then a 64. Okay, so what I do is I rewrite it first. I think I showed you guys in the last video. I'm going to use one big parenthesis here. And on that Z, I'm going to go ahead and stick an invisible power of 1, since there's nothing written. Okay, there's nothing wrong with doing that. And then what does this 3 mean? Well, it means that when I come out here, this is all to the 1/3 power. Okay, now I'm going to distribute my 1/3 to every single term. So it's 48 to the 1/3, it's x to the 3rd to the 1/3, y to the 7th to the 1/3, and then z to the 1st to the 1/3. And now, before I do my number, let me just go ahead and distribute and multiply these, okay, just because I don't like all these numbers. Okay, so what's the rule? Well, you multiply a power to a power, so that's x to the 1st, y to the 7th, so 7 times 1/3 is 7/3, because you're supposed to multiply those, and then a 1 times a 1/3 is a 1/3. Okay, so now I feel like I'm ready to deal with it. Okay, so what I want to do is look on this list and see if any of these numbers go into 48, and 8 does, right? It's 8 times 6 is equal to 48, and both of these are still to the 1/3 power. I'm just rewriting my number. Now, what is 8 to the 1/3? Well, that's the same thing as the cubed root of 8, which leads back to 2. So from this 8, it's going to become a normal 2, but there's still a 6 there, okay? So it's going to be 6, still has the 1/3 power on it, okay? So I just break it down right underneath. If it comes out of the 1/3 exponent, then I write it. You can even put a power of 1 on it if you like, it doesn't matter. And then 6 was left over, so I had to do that. All right, now we have x to the 1st, y to the 7/3, and z to the 1/3. Okay, so here's where it gets interesting, okay? What you're going to want to do is group the stuff that you're going to want to start, you're going to want to start sort of a two-part problem. Your final answer on these usually goes back to a cubed root, where there's some stuff underneath and there's some stuff out front. And this is a good point in the problem to decide who's coming out and who's staying under. Now, the stuff that's going to come out front is the stuff that, you know, is now has just a normal exponent on it without the 1/3. So that 2 is actually going to go to the front because we pulled it out of this. And that x, whenever that 1/3 and that 3 canceled, it became a 1. It's also going to be out front because there's no 1/3 anymore, okay? But these I need to think about because they all have the 3 in the denominator, so they could potentially go here. And all that you do is sort of talk yourself through it. Now, 6 to the 1/3 we already talked about. It has to go back under the cubed root. The y to the 7/3, what you want to do is talk yourself through the division. 7 divided by 3, right? Okay, so what that's asking is, how many times does 3 go into 7? And if you don't want to think about it, if you just want to turn it into a mixed number, you can, because what would happen is, let's see, 7 over 3 is the same thing as 2 and 1/3. So I like to just talk myself through it and say, oh, okay, well, 3 goes into 7 twice, which means that a y squared is going to come out here, and then the remainder on that is a 1, so a y to the 1st will stay under. Okay, so let's do that again. However many times it goes into the numerator is how many you can pull out front. Whatever the remainder is when you do the division, that's how many stay under. And then here, 1 and 3, I mean, 3 doesn't go into 1, so that just means that you have a z to the first still left over down below. And this would be your final answer. Okay, we're going to do one more a little bit quicker, okay? Okay, so if this is my problem, I noticed a little 4 and started thinking about the numbers on my chart, 2 to the 4th, 3 to the 4th, so on and so forth, okay? I'm going to start with the rewrite, and everybody is to the 1/4 power. So we've got 48 to the 1/4, and this part I'm going to go a little faster. It's a to the 5th to the 1/4, but you're really just multiplying those. So 5 times 1/4 is 5/4. This will be b to the 3/4. This will be c to the 8/4. All right, now I'm going to do my number part, okay? So I need a number from this list to hopefully go into 48. Now this does break down to 16 times 3, which means that the 4th root of 16 is a 2, but there is no 4th root of 3. So I'm going to go ahead and start my radical with the 4th root over here, and that 3 that was left over is going to go underneath, okay? Now let's talk ourselves through the variables. A to the 5/4. 4 goes into 5 one time, so I pull out an a to the first with a remainder of 1, right? 5 divided by 4 is 1, remainder 1. So the remainder 1 goes underneath. B to the 3/4. 4 does not go into 3, right? Like this is smaller than this. So that means the entire b cubed has to stay underneath because we can't do the division. And then c to the 8/4. Well, 8 divided by 4 is 2. And there is nothing left over, so that means there will be no c term underneath. So this would be your final answer. You don't need to write all of the little ones, but you do have to recopy that. Make sure you're recopying the index, okay? And that would be your final answer.